All right, so the first one wanted you to list all of the details, right? They want horizontal asymptotes, holes, vertical asymptotes, x and y intercepts. All right, so you want to list all of those out here because I need something written for each one of those. All right, I need you to write, even if there isn't one, you need to tell me none. So for this one, I would start with my horizontal because that's my shortcut. In this case, it is the same degree on the top and the bottom. So my leading coefficient on top is 1. My leading coefficient on bottom is 4. So my horizontal is going to happen at y equals 1/4. All right? That is where I get this from, right here. The 1 and the 4. That's my horizontal. All right? The next thing I would actually do is my y-intercept. All right? For my y-intercept, it is going to be where all of my x's are 0. So I have 0 squared minus 3 times 0 plus 2 over 4, 0 squared minus 16. That gives me 2 on top, negative 16 on bottom. That reduces to negative 1 over 8. So my y-intercept happens at 0, negative 1/8. At this point, I'm going to factor, okay? This is where I start factoring. So I'm going to factor the top. The top is going to be factors of 2 that add up to 3. That's negative 2 and negative 1. On the bottom, this, I'm going to take a 4 out first, and I have x squared minus 4, which is x plus 2x minus 2. Okay. My holes happen where my denominator is 0 and it cancels, all right? So that happens at x minus 2. So that's when x equals positive 2. That's my holes. My vertical happens where my denominator is 0 and it does not cancel. That happens at the x plus 2. So that's going to be at when x equals negative 2. That's what makes that 0. And my y-intercept happens where my numerator is 0 and it has not canceled with anything. That happens at 1. So that is a point. My x is 1. My y is 0. So simplifying, this should be easy after doing that one. Factors of 36 that add up to 13. Yes. 9 and 4. All right. Factors of 4 that add up to 5. 1, 4, right? If I'm simplifying this, I'm going to cancel what I can cancel. If everything cancels on top, by the way, it is a 1. But this one is like that. That is your final answer there.
Not putting the
no discontinuities for those because you've already gone through all the discontinuities on the one before it. All right, multiplication and division. So multiplication and division are the same, but keep change flip. So I'm going to keep this one. I will go ahead and factor this. Factors of 56 that add up to negative 1. I'm going to flip this, change it to multiplication and flip. So this is my numerator. Take out a 10. The bottom is now going to look like this. And then I'm just going to factor any numerator to any denominator. That means that cancels, right? The x minus 1 can cancel. The 10 cannot. The x minus 8 cannot. The x minus 2 cannot. All right? And so my final here is going to be 10 times 1. Just multiply across. On the bottom, you can leave them factored. You do not have to FOIL. I want to factor the numerators here. N minus 3 doesn't really factor here. What can I take out of this right here? I can take out a 6, right? And I'm left with what? 5n minus 6. So my common denominator here... and actually, think about this. You can simplify before you go. So, like, I have a 3n over n minus 3 minus 6n over 6 in 5n 5n minus 6. I can actually, you would simplify fractions before you added them, right? So I can actually simplify this 6 out before I add. So my common denominator here is going to be n minus 3, 5n minus 6. All right? And so my numerator is going to be the 3n times what it is missing. What is this missing from my common denominator?
5n minus 6.
5n minus 6. And I'm going to say minus. The n is what's left. And what is this one missing?
N minus 3.
The n minus 3. And so I'm going to distribute the 3n through. So I get 15n squared minus 18n. Distribute negative n through. Minus n squared plus 3n, and it's over that denominator. Leave the denominator alone at this point. All right, final answer is going to be that simplified. 15 minus n is 14n squared. Negative 18 plus 3 is negative 15n. Leave your denominator alone. So this question is wanting us to simplify, and what you'll want to do is you want to find the common denominator among all of them. So for this numerator, the denominator is 1. For this left-hand side, your denominator is 3. And for this right-hand side, your denominator is u plus 1. So your common denominator is going to be 3u plus 1. So what you'll want to do is you will want to multiply everything by the 3u plus 1. So that's every piece of it. Cancel what you can. On the top, you can't cancel anything. So you can just take this 9 times 3 and distribute it. So you have 27 times u plus 27 times 1. And then on the bottom here, the 3's will cancel. And you have u plus 1 times u plus 1. You'll need to FOIL that out. So you'll end up with u squared plus 2u plus 1. On the right-hand side, the u plus 1 cancels, so you can just distribute the 3. So you end up with 9u minus 27. And then from that point, you'll just want to combine like terms. In the denominator, you have the u squared, the 2u, and the 9u, and then the minus 27. And that would be your final answer here. For solving equations, you're going to want to do the same exact concept here that we just did for simplifying. You want to find the common denominator, and you will do that by factoring. So factors of 20 that add up to 9 here. That's how this factors. This is the same exact factoring. And then, of course, this is already factored. So your common denominator is simply going to be the n plus 5, which shows up in all of them once, and the n plus 4. So you're going to multiply everything by the n plus 5, n plus 4. And then you are going to go through and cancel anything that you can cancel. Of course, the entire denominator cancels here, so you're left with just a 1. Minus, the entire thing cancels here, and you're left with an n minus 6. You'll notice I put parentheses around it because you're subtracting the whole group. And on the other side, just the n plus 5 cancels, so distribute that 1 through, and you have n plus 4. To solve here, you need to distribute this negative 1 through. So we have 1 minus n plus 6 equals n plus 4. Combine your 1 and 6, you get 7 minus n equals n plus 4. We are going to move all of our variables to one side and all of our numbers to the other. So you end up with 3 on the left-hand side and 2n on the right-hand side. divide both sides by 2, you get n equals 3/2. You do need to make sure that doesn't cause a problem in any of your denominators. If you were to plug in 3/2 to any of these groups, it would not cause a 0. So that is your final answer there. The next set of questions is asking for the probability here. The first thing it wants you to do is figure out if they are independent or dependent events, and then you will find the probability of each one based on whether or not it is independent or dependent. So it's letting us know we have in our sock drawer, we have 2 white socks, 6 brown socks, and 2 black socks. You randomly pick 2 socks and get a matching pair of black. So that means we want the probability of a black sock and the probability of a second black sock. Since it says I get a matching pair, it indicates I'm not putting the socks back in. So I have to determine that those are dependent, because if I pull a black sock out, it does affect my second pull. And you want to assume that you actually got what you were looking for on these. So my probability then of pulling a black sock the first time is going to be my 2 black socks over the total number, which is 2 plus 6 plus 2. So that's going to be 10. And then the next thing I'm going to do is my probability of a black sock again. Well, now I only have 1 black sock left, and I have 9 left to choose from. And so when I do that, that is my second probability. You can reduce before you multiply. You could cross cancel if possible, and you can cancel up and down. Once you've canceled, just multiply across. You get 1 out of 45. So my 2 answers here would be that it is dependent, and the probability of doing that is 1 out of 45. If I ask for that in percentage, if I say find the probability, the exact probability, I will want a fraction. If I ask for percentage, you will put that into your calculator, and you will tell me 2.2%. The last type of problems that we looked at were mutually exclusive and not mutually exclusive, where we were just adding up the probabilities here. So they tell me that there are 11 shirts in your closet, 5 blue and 6 green. 3 of the blue shirts and 2 of the green shirts fit well, the others are too big. You randomly select a shirt to wear. It is blue or too big. So we're going to look at the probability of it being blue, and we are going to add that to the probability of it being too big. And we are going to subtract the probability of it being both blue and too big. So the probability of it being blue, well, I have 11 shirts altogether, so my denominator here is 11. It tells me that 5 are blue, so that's the probability of blue. Then I'm going to look at the probability of too big. Now think this is just one pull of a shirt. We're not doing 2 different pulls like we did in the last problem. This is 1 pull with 2 descriptions. And so now the probability that it is too big, it tells me that 3 of the blue and 2 of the green fit. So 5 of them fit well. The rest out of 11 are too big. So that means 6 out of 11 are too big. All right. And then I'm going to do the probability that they are both blue and too big. So I still have 11 shirts. 3 out of my 5 blue fit me well. So that means I have 2 out of my blue that are too big. So 2 out of the 11 are both blue and too big. And so I'm just going to add those up. I'm going to say 5 plus 6 is 11, minus 2 is 9. So the probability is 9 out of 11. If I ask for it in percentage, you would tell me 81.8%.